Hi everyone, welcome to section 5.3. Today we are going to be learning a new formula for trigonometry. It's called the sine law. So let's take a look at this triangle right here. I want you to think about whether or not you can answer it using Pythagorean's theorem, and then whether or not you can answer it using or solve it using SOHCAHTOA, your primary trig ratios. So if you take a look, we can't use Pythagorean's theorem for two reasons. One, I only know one side, I would need two. And the second reason is that it's not a right angle triangle. So we cannot use Pythagorean's theorem. So let's try our primary trig ratios. I've got a side and I've got an angle. That's perfect. And I can find another side. But when you look at your trig ratios, they would involve, some of them would involve a hypotenuse, which would be the longest side. So that means I would have to have a 90-degree angle in here. And I don't. This is not a right angle triangle. Your primary trig ratios only work for right angle triangles, and that includes the tangent ratio. All of them have to be a right angle triangle, and this isn't. So in short, this doesn't work. Our primary trig ratios and Pythagorean's theorem, our previous formulas, they don't work for triangles that would look like this. So we need a new way to handle these. So there's something called the sine law. Now, before we actually get to the sine law, there is one other thing that I want you to realize. So we're going to look at a separate triangle. This is a 90-degree triangle, and the reason I picked it is so you could actually verify all of the angles and sides. So if you were to draw one out yourself and measure it with a compass and a protractor and a ruler, you should get all of these angles. So consider a triangle ABC. If I take the sine of an angle, so let's say sine of 36.8, and I divide that by 3 divided by sine of 36.8, I'd have a fraction set up like this. And if I plugged it into my calculator, I should get about 5. Now, depending on how accurate my measurements were, you might get 4.99 or 5.01, but you would get about 5. If you take a second side, so now I'm going to look at angle B and side B. Okay, they're across from each other. So angle B is 53.2. If I take 4 divided by sine of 53.2, because they're across from each other, I should also get about 5. And then if I do for the third one, if I take 5 and I divide it by sine of 90 is 1. 5 divided by 1, I still get 5. So regardless of which side and its opposite angle I look at, so regardless of whether I look at these two or these two or these two, when you divide them, you get the exact same answer. This is basically the idea behind the sine law, is that these ratios that you've created, or these fractions that you've created, are indeed equal for every set of angle and its opposite side. Okay, so this is what your sine law looks like. If I am finding sides or angles, it doesn't matter, I would take the side divided by sine of its opposite angle. That ratio is equal to side B divided by sine B. And that is also equal to C divided by sine C. Now, I would never use all three of them. I would only pick the two that I need in order to solve whatever triangle I'm dealing with. Now, you can take this ratio and you can flip the entire set of fractions so it looks like this, and you're allowed to do that. They are both the sine law. We use this one to find sides. So if the sides are up top, I'm finding sides. And if my angles are up top, so the sine of the angles, I find my angle. Okay, so if I have any triangle ABC, whether or not it's a right angle triangle, the sets of opposite sides and angles will be equal to each other. So just remember that side A has to be across from angle A, side B has to be across from B, and C has to be across from C. Just like your formulas, side C would have to be on top of sine of C. Okay, so they have to be the same. Okay, so when can we use this formula? There are some conditions, and you will learn another formula tomorrow. But these are the scenarios where you can use your sine law. So if I have a triangle and I know this side and an angle that is across from one of my sides or opposite to one of my sides, I can use the sine law. The other scenario is if I have any two angles and any other side, I should be able to use the sine law. Okay, so those are the two scenarios where you can use your sine law. Okay, let's get into some examples. There we go. Okay, so consider this particular triangle here. I have two angles and I have two sides. You would notice that this angle is across from this side. So that's one set of, I call them opposite ratios. So that's one set of opposite ratios. And then this 55 is across or opposite to this x. So I would need two sets of opposite ratios to use my sine law. So this checks out. I've got the two sides, two angles and a side. And we're just going to scroll down a bit. So I need to set this up. Since I am looking for a side, I'm going to put my side up top. And then it's going to be over the sine of the opposite angle. So this is going to be over sine of 55. That ratio will be equal to these guys, or this ratio. So I'm putting my sides up top, so that'll be equal to 9.2 because it's the side, over sine of the opposite angle, over sine 70, which is here. And when we're using our sine law, like I said, I only need 2 out of the 3 sets. So I've basically got 3 out of my 4 unknowns, and now we can use our algebra in order to solve for x. So let's scroll down a bit. And I need to get x by itself. So since this sine 55 is dividing x, to bring it onto the other side, I'm going to multiply both sides by sine 55, and the sine 55 is going to come up. Okay, now I know that they do a whole bunch of fun math over here, and they make it look really scary. Take the sine 55, bring it up top. It goes away here and here, and you are left with x equals sine 55 times 9.2 over 70, sine 70. Okay, here it is. It just looks a little bit nicer. Now turn each of these into a decimal, and then you can plug it into your calculator. So let's just take a look. Sine of 55 is 0.819. And if you round properly, you should get 8192. And then sine of 70 is 0.9396. And we'll round to 97. Okay. All right. So now to figure out x, take 0.8192, multiply it by 9.2, and divide by 0.9397, and you should get approximately 8.0. Might be a little bit off, might be 8.1 or 7.99. That's fine. Okay, so you should get around 8. Okay, so that's one way that you can use the sine law. Now, this is finding sides. We can also look at an example where we're finding angles, and I do want to see one of those also. Okay, so consider this one here. This triangle does look a little bit different. It's not a right angle triangle, so we cannot use Pythagorean theorem or SOHCAHTOA. So now we have to see if we can use the sine law. The sine law states that I would need, if I have 2 sides, I would need an angle across from one of the sides, which means I either need r or I need the angle in here. They didn't give it to me, but they did tell me that the outside is 124 degrees. You should remember, I think from grade 9, that if you have a straight line, it should add up to 180 degrees. So this should be 56 degrees in here. Okay, so now I can set up my sine law. So since I'm looking for an angle, I'm going to write it where my angles are up top. So I'm going to write sine of 56 is going to equal to sine of whatever r is. But under those, okay, so sine of 56 has divided by 98. Oops. And sine r is going to be divided by 112. Okay. So basically what we've done is we've created a little bit of a fraction here. Okay, so let's go down. The first step that they show you is taking 180 minus 124 to get this inside angle. Then they set up the ratio like we did up here. They just put the unknown on the left-hand side. I do actually like doing it the way that they've done. Okay. If you happen to set it up this way, that's okay. Just write the fractions the other way when you're ready to do your math. Okay. And then they need to get the r by itself. So they take the 112, multiply both sides by 112 to bring it onto the other side. Okay, so take this 112, both sides are going to get multiplied. So we can now erase these. And you have this fraction. And now I need to figure out what this right-hand side is going to equal. So I'm going to convert sine of 56 into a decimal. And if you plug it in, you should get around 0.829. I'm still left with this kind of fraction. Take 112, times it by 0.829, and divide by 98. You should get 0.9475. And again, I think I rounded there. In order to get the r by itself, this is very similar to what you did with your trig ratio stuff. I need to take the opposite of sine, which is the inverse sine, and bring it onto the other side. So r will equal the inverse sine of this number, and you should get about 71 degrees. Again, it might be a little off, and the question wanted you to round to the nearest degree. Okay, so let's go back up. So we know that this is 56, this is 71, and the question asked for all of the interior angles. So in order to solve for Q, just take 180 minus 56 and minus 71. Okay, so down here, that's all that they're doing to get the third angle. So we've got our 3 angles for our triangle, and they gave us the 56. Okay, so we can use our sine law to find sides. We can use our sine law to find angles. Most importantly, make sure you are setting up the sides and the angles that are opposite to each other. Okay, good luck, and we'll see you